In the heart of the Texas desert, a massive industrial war is being fought.
Most people see a border, but engineers see a billion-dollar masterclass in logistical struggle. We are looking at a structure that defies the very laws of the desert. Imagine building a continuous spine across miles of shifting, unstable, and unforgiving river sand.
The ground beneath our feet here is the biggest enemy of this massive project. If the foundation moves even a single inch, the entire structure faces total collapse.
We are going inside the forensic process of building this intense digital border wall.
It is not just about the fence. It is about the cold, hard engineering.
Can a 1,000-mile concrete spine really stand against the brutal reality of Texas heat? The mixture had to be perfect to withstand the extreme shifts in desert temperature.
If the concrete set too fast, it develops tiny micro cracks that weaken the base.
Every detail is calculated to survive the harsh cycles of the boiling Texas sun.
It is a brutal, noisy, and absolutely necessary step for any long-term structural success.
Specialized cranes lifted each panel, placing it with a grace that defied their size.
Welders worked in teams, their torches lighting up the night like thousands of stars. The smell of burning metal filled the air, a reminder of the raw power.
Each weld is inspected by experts to ensure it can hold its own weight. These panels were designed to flex slightly, absorbing the energy of the heavy winds. It was a clever bit of engineering, turning rigidity into a form of strength.
If the wall were too stiff, the desert wind would simply snap it apart.
The workers climbed high, secured only by thin ropes that looked far too fragile.
You have to admire their courage, facing that height in the blistering summer sun.
They were the true heroes of this project, putting in the hardest physical labor.
Every bolt was tightened to a specific torque, recorded in the master project log. There was no room for error when building something meant to divide the land.
The heat was so intense that the metal burned their skin through the gloves.
The site hummed with the sound of power tools and the shouting of crews. It was a beautiful, chaotic symphony of progress that continued throughout the long year.
But a wall without eyes is just a barrier, blind to the surrounding vast wilderness. Looking at the skeleton, you could finally see the true scope of the vision. The next phase involved installing a complex nervous system beneath the shifting desert sand. It was a digital upgrade that turned simple steel into a modern surveillance machine. These cables connected thousands of sensors that could detect even the slightest ground vibrations.
They integrated thermal cameras that could see through the thickest fog or darkest night.
Screens displayed real-time data, tracking everything that moved within the project's massive wide radius. The control center looked like something pulled straight from a high-budget science fiction movie.
It was the perfect marriage of rugged physical construction and advanced, cutting-edge digital intelligence.
The live feed looks stable. Check the amplitude against the physical movement.
See that spike right there?
They needed to ensure that no false alarms would waste the valuable security resources.
It is a massive game of cat and mouse played out on a screen.
The technology is constantly being tweaked, updated to match the changing environment's many challenges.
You could feel the tension in the room whenever a new update was installed.
But when it finally worked, the data flow was smooth, accurate, and truly impressive.
They had successfully created a border that could see, hear, and process all information.
It is a testament to the fact that modern infrastructure is mostly about software.
The desert is a harsh master, testing every material with its cycles of heat.
Expansion and contraction are the silent enemies that could destroy everything they had built.
They installed specialized joints that allowed the long steel panels to breathe and move.
Without these simple, clever pieces, the entire structure would have buckled years ago now.
They also had to fight the constant threat of erosion from the seasonal floods.
Water rushing down the riverbeds could scour the earth from beneath the solid foundation.
They placed heavy boulders along the base, creating a rough, natural-looking stone protective barrier.
This concrete plant is showing red. We need to reroute supply chain Bravo immediately to maintain the fuel levels.
They had to build secondary roads just to reach the most remote project sites.
It is an exercise in extreme efficiency, where every wasted minute meant lost money.
If we move the heavy equipment schedule up to Q2, we save 3% on fuel.
That works. I'll adjust the forecast model now.
It is a massive, complex logistical puzzle that keeps them awake during many nights. But slowly, the wall begins to look like a permanent part of the horizon. You see it stretching toward the desert edge, a testament to human sheer willpower. It stands defiant, a silver line cutting through the endless brown of the land. Despite all the challenges, they are reaching the final, highly anticipated construction milestone phase.
The project feels like a massive, permanent sculpture made for a very different future.
The final panels are set into place with a quiet sense of real accomplishment. There were no grand ceremonies here, just the tired smiles of the expert crew. They look back at the miles they have conquered with their own two hands.
The project stands tall against the backdrop of the setting, hot Texas desert sun.
It is a physical reminder of what we can achieve with enough focused effort.
Whether it will stand for 10 years or 100 remains to be seen.
Engineering is always a gamble, a bet against the inevitable power of the Earth.
But for now, It stands as a peak example of modern, high-tech industrial design.
Look at how the blocks are fused together.
It defies explanation. The sheer magnitude of it is staggering.
They will see the steel and the sensors, but miss the human-led hard struggle.
I hope this forensic story helped you appreciate the invisible work behind such structures.
Building in the wild is a rare challenge that pushes every limit of capacity. If you have ever wondered how a massive border gets built, you know now. It takes steel, sweat, silicon, and the courage to ignore the many doubters' voices. Engineering is about solving the impossible, one small, concrete, and heavy step at a time.
Let me know what you think about this intense feat in the comments below.
Does this structure deserve to be called a modern, high-tech, and amazing engineering marvel?
The migration patterns here don't align with the historical data, Doctor.
No, the anomaly suggests recent activity. We should prioritize this sector for the next phase.
Your feedback helps us decide which giant structure we should analyze for you next. By understanding how these things are built, we respect the power of our species.
Thank you for staying with us until the very end of this long story.
Engineering creates the world we live in, but rarely do we see the process. The desert is quiet now, but this wall will stand as a permanent mark.
As you can see here, the structural load distribution shows critical failure points in red. We need to examine this closer.
If you like this breakdown, make sure to hit that like button for us.
Until then, keep looking at the world with the eyes of a true engineer.
Our journey across the border ends here, but the engineering legend will live on.
We will be back soon with another massive project that defies the physical laws.
Stay curious, stay sharp, and we will see you in the next big project.
This is the story of how men and machines conquered the vast, empty wilderness.
We are stripping away the political noise to focus on the raw industrial facts.
Every single segment you see here represents thousands of hours of intense human labor. It is a project that pushes the limits of what civil engineers consider possible.
Let's dive deep into the forensic details of the most high-tech border today.
To build anything this big, you must first master the unstable desert floor beneath. The soil here is alluvial sediment, basically loose dirt left by ancient riverbeds.
Look at the consistency right here.
The gauge confirms low plasticity at 2 meters.
Engineers chose deep foundation piling as the only way to anchor this massive heavy steel. Giant hydraulic drills bite into the earth, searching for something solid to grip firmly. They push steel pylons 30 feet down until they hit the hard desert bedrock. Each pile acts like a giant, buried tooth, holding the wall against the wind.
Dust clouds erupt into the air with every single strike of the heavy hammer.
But beneath that grit, the team was creating the strongest spine ever built here. They poured tons of high-strength concrete, ensuring it flowed into every single jagged crevice.